The first part will be a very short presentation of the processor. Okay, before go to that, let's show you the details. Okay, no. Okay, so it's come to this page. There's a lot of uh, detailed information for the processor that we use to do some exercise. Okay, most of the assembly language level will be uh, practiced using this instruction. Okay, which is not totally different, slightly different in syntax from RISC-V. Okay, you can choose to download and use the tools in available in the public domain for RISC-V. There's quite several tools for that, including the one available in textbook, I think. Let us talk about this. We will go into detail later, much later on. So, okay, uh, let's see the let's see the instruction type first. Right. Similarly to RISC-V, we do add and subtract, and the rest you don't have to worry. Okay, because we just do some compare and then add. So the other thing you don't have to understand. Okay, right. And the quiz at the end of the lecture will be using RISC-V. Okay, right. This is just for demo. I just demonstrate for you. Okay, so this is a kind of for the control we can use the logic of the comparing. Okay, I slightly different from RISC-V is that we do logical comparing and keep the result, then use this result to do branch. Okay, so we have to do if equal, then we have to use instruction equal, and then we know the answer is true or false, and then use this answer to do jump if true or jump is false. All right. The RISC-V do a combine, right? Branch if equal, branch is not equal, and right. So we have to talk a little bit about the. Do we? No, we don't have to. So right, we have very similar, just like let me check if all of you already did the first quiz. Otherwise, I will spoil the solution. Boom. Almost, yeah. Just of just 2 or 3 students haven't submit. So yeah, it's very much what you know. So when we try to write this assembly, right, we just have to know instruction like this. Add, right? It's very similar to RISC-V, but I don't have add immediate. Right? I just add immediate. The syntax is similar to add, but the last operand will be prefixed by hash. So this is become a small number. Okay, that's all you have to know. And it's similar to other kind of instruction. Okay, have 2 mode. One is 3 register, and then the other is 2 register with 1 small number. Okay. Okay. Right. So you have this kind of instruction, and yeah, I also show you a small program when it convert to this one. All right. All right. So the detail is here. Let's go back to a short presentation of the instruction. Okay. So it's here. This is for the demonstration. It's not for you to really. Oh well, I asked you to do the homework using this tool as well. So let's see. Okay. So we already have it. Okay. All right. So this is instruction of S2 processor, which is the simulate processor that we use to demonstrate. Okay, it's a 32-bit. So the instruction is 32-bit, and there are 32 register. Right, this is a picture which we understand when we study more of the processor design. Right? So the meaning the same. Add R0, R2, R4 is mean adding two registers together and store in this register. Okay, this we already know. This I already mentioned. Okay, all right. So in the exercise, similar to RISC-4 is this one. Load a register and then small displacement and the base register. For S2, the syntax is very much simplified. You just have to have had this curve, right? And then the displacement, small number, and then the base register. Right? And then we have something like move data between register, which you will use from time to time. You want to move data between register, right? This means move from the right hand to the left hand, right? Because the first operand always the destination. Okay. You can also move some value into register. Okay. Right. And the jump, as I mentioned. Okay. Let's do some demonstration. Okay. Oh, the simplest one here. All right. So we already see how RISC-V instruction perform. Then we run to show you the actual running, okay, with the tools. The tools is available here. All right. So you just unzip it, and I think it includes all the executable. This is for Windows. When you unzip it, you will have this S21 S21 directory, right? And inside directory, one unzip, you have this. One is the assembler, right? And if you want to really execute it, you need the processor simulator. So it's called Sim21. Okay. And the last directory is storing all the example. Okay. So let's start with the simplest example. Okay. For the format here, that is maybe I have to tell you a little bit is you have to start the first line with dot code 0. Okay, so it told the assembler where to store this machine instruction, right? And at the end of your program, you have to say dot end. Okay, that is a kind of idiom. You just write it like this. Okay. Now we put our attention into the machine instruction itself. So in this file we have three instruction. One is we keep the number 20 to register 1, number 30 to register 2, and then we add uh, these two values together and store in register 0. Okay, and uh, this one is we store is as a text file called add.text, right? Okay. Next is ooh, hmm, Okay. I open my terminal. Okay, it's called command prompt. Okay, this is you do that by command prompt. Oh, easier to type, right? Type TMD. Right, and this application, this terminal will appear CMD. All right. So that's how I start my terminal here. All right, and I change my directory, which you can do by change directory. If you are not familiar with this DOS, then you can query the uh, let's see, let's change it. So I change it to the when it start it in the main disk we call drive C. Then because this uh, this whole program is in my drive C at the directory temp, and when I unzip it, it becomes S21, and I kept all the example program in directory test. So I have to change my, let's go here, cd/temp/S21/test. Then it arrives here, and we can check the content of the directory using dir directory, right? And it have a lot of things, including the program we just show you add.text. So we type it down. It's just 5 lines of program. This is our program of machine language, assembly language, right? So we want to use the assembler to change that into object code. Let's do that. The program is called AS21. Okay, add.text. Boom. Okay, stop. So we want to see what it has. So the source program is add.text, and assembler produce 2 files. One is add.list, the other add.object. Let's see add.object first. This is the machine code that is print out for human to see. Okay, because it is my own format and I can do anything I want, right? That you can see this is produced 3 lines of code, right? The first line A0 correspond to the special instruction to let the simulator know where to put this instruction, where to store this machine code. And E, the last line E is the end of this object code. So the immediate 3 line is the matching code in binary. In this form is in base 10 form. So you probably can know it, right? And if we type add.list, if we give you correspondence between, this is for human consumption only, no meaning. For object code, it will be used later for the run program, but for list is for human to see that I use this to check if my program correct. Okay, right. If I write some very funny machine code, it may not be able to assemble it. Okay, so next is we try to run it. Because sim21, the simulator run on the object code only. So add.obj. Okay, boom. So it's load program correctly. And because it's 3 instructions, so it's 0, 1, 2. The last program is address 3. Okay. This simulator can do a little bit of things. So we type help H and see what it do. We can run one step, or we can do a lot of things. At the end, we can quit. Okay, so quit here. Okay, we go again. We want to see the register, then we call R. No, yeah, R is show register. So all the 32 register is shown here with its value. Okay, initially it's all 0. Okay, so let's execute the program. The first line of program is to move the value small number 20 into register 1. So we single step T trace one step. So it moved 20, right? And you can see the value of register 1. I have to use the correct mouse here, right? 20. All right. Next instruction is move 30. So R2 become 30. Okay. And then next instruction is to add, and then R0 become the result of this operation. Then that is stop, right? So we quit. So for demonstration, you can try out this very simple sequence of program, and then step. Right? Once you click it, it's finished. All right. You have to bear in mind that when the instructor demonstrates something to you, it's all perfect because it's all we prepared beforehand. We did not show you the error, all right? Otherwise, it will take a bit of time. But it is when I first write my assembly program, is always get something error. Okay, so don't give up too easily, all right? When you want to try, the purpose of this tool is, of course, today we explain things and you write in paper with paper and pencil, right? But if you want to make sure the program do what you want, you have to do this kind of actual running the program, right? So you have to go through this step. That's why I demonstrated to you. If you don't want to do it, it's okay. But well, practice make perfect. If you don't practice, then you just know you cannot do.